And Pythagoras had a rule like you see right there, c squared equals a squared plus b squared. What does that mean, Ms. Vaj?
Okay, that means that if you have any triangle, and maybe I'll just make one up, and it has to be a right angle triangle, that if you know two of its sides, so two of the shorter sides, you can, and this is always the c squared, it's always the hypotenuse, you can square the two sides, add them together, and then
figure out what that longer side is. C equals 5. So using Pythagorean theorem, we can determine the third side if we know two sides, and it has to be a right triangle.
Has to be a right angle. Has to be a right angle. Remember that. Okay, let's move on to trigonometry. So,
look at that nice picture of that bird singing.
So katoa.
And I like to remember this as socket to ya. But first of all, these are the rules that we can follow if we have a right triangle.
Yeah, it's all right now dealing with right angle trig, okay?
And if you remember, let's just go through quickly. Sine is the opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. So what does that mean, right? First of all, we have to find the sides of every right triangle.
Always start by labeling the sides, right?
First step, labeling the sides. And we label the sides based on the angle of reference.
Yeah,
so
we start with the angle that you're working with.
the angle you're working with is your angle of reference, and from there you label your sides.
Okay, you can always start with the hypotenuse. That will not change. The hypotenuse is always the longest, and it's always across the 90-degree angle.
Right.
Okay.
Then we have the opposite, and that's across from your angle of reference. And that's your O, or your opposite. And then we have the last side, which is adjacent.
And adjacent is another word for next to. So,
yeah, next to, I like to sometimes think about it, it's the angle that it's touching.
Touching's
right?
good.
So the side that's touching that angle is your adjacent.
Good.
Once you have the sides labeled, you can then figure out what any angle or side is, depending on what information you're given.
So you're just to repeat about what it says there in that table. So if you want the sine of the angle, then you would put, okay, so that's the opposite over the hypotenuse.
And that's where the
S-O-H,
comes from.
and so on. And you can do that for the other two.
Right.
Should we do some problems?
Yep, let's do an example. So if we want to find a side and we know what the angle is in one side, we can always determine what the other side is. So let's set this problem up here.
Okay.
That's our reference angle.
Angle of reference, 40.
Let's label the sides. That's your first step.
Okay, so now be careful. Here, the right angle, it's the triangle is turned, right? So the hypotenuse is not this one, it's this one. It's always across the 90 degrees. So that's your hypotenuse. Remember, the opposite is across the angle of reference.
That's opposite.
And touching.
Touching. Adjacent.
Adjacent.
So let's look and see what we have. We have x as our hypotenuse and we have d as our adjacent. So we know we have so, ka, toa. Which one are we going to use?
Okay, well, look at the two sides that you're dealing with. I'm interested to working with the A and the H. I don't know the opposite, and I'm not interested in the opposite. So leave the O out of it. It's just the A and the H. So there it is, right? Adjacent and hypotenuse. So it's going to be the cosine
of 40 is equal to adjacent over hypotenuse.
Okay.
Good. So in this example right here, what if our side, let's say our adjacent side is 5.
Let's do the hypotenuse.
You want to do the hypotenuse? Okay, let's say the hypotenuse is 5. So we're going to fill in or substitute in for x. We're going to put 5. Now let's solve.
Okay, now is the easy bit. You guys have the algebra skills for it. To isolate this, you just multiply
both sides by 5.
Both sides by 5, okay? And this is now purely calculator work, okay? So go in your calculator. You might want to check mode. This is important. You see I'm in radians. That's bad. All the work that we're going to be doing is going to be in degrees. So just check that you're in that degree mode. Otherwise, your answers will be completely wacky. Okay, and now we can just do 5 cosine 40. Okay.
Equals. Good. And we
Equals.
always want to write that then to three significant figures.
Right. And I like to put the approximate sign because we are rounding.
Good. What's next? What if we want to find an angle and we know two sides?
Ooh, okay. Angle of reference, labeling first.
Yep. Then we have, that's my opposite. The one touching is the adjacent. And then across from the 90 degrees, you want to put it on there as well, or not really? We don't have to. Hypotenuse. Good. So, as you can see, we have the adjacent and the opposite. Oh, no, adjacent
Yeah,
and
this is
opposite.
the opposite and the adjacent. O and the A. So look for it. O, A, which means it's tan. So we have tangent of theta. And what I'm saying here, I'm sure you know this. Oh, I should have put it there. But this is fancy Greek word for theta. You'll remember it from 8th grade, yeah? Just that's the name of that letter.
That's a symbol for an angle.
It's like X.
Yeah, it's like X.
Except in the angle world. Okay, so opposite.
We know tangent is opposite over adjacent, and so let's just substitute in. What's our opposite side? 2.7. Adjacent, 3.1.
Okay. Now, see if you want to pause it and see if you remember how to now get the angle to be on its own. Okay, maybe you're already remembering this, right? And God forbid you divide by 10. Oh my God! Oh, that's
10 is dividing by 10 is bad.
Lightning will strike.
On our calculator, what we use over here is. Do you want to write it out? The minus.
Yeah. It's right here. It's the inverse of it.
Inverse of it.
Okay? So you're going to have the inverse, because now you're saying, hey, give me the angle that gives me this ratio between sides, okay? So for angle, always inverse, tan, -1. And then you have 2.7.
Simply put in the ratio divided by 3.1.
Okay, and you should have, now this is an angle answer. So it should make sense to be an angle answer. Like if you're getting 0.23, you might be in radian mode or you did something wrong. It should be some kind of a logical answer.
The other thing we know is that if you look back up at your triangle, it should probably be less than 90, right?
Yeah, absolutely.
So if you're getting an answer that's like 98, 104, whatever, then you've
done something wrong. Exactly. So there you go, okay? So just remember, you might want to put a little bubble in your notes. Find angle.
A bubble in your notes. What does that mean? Oh, we like that. Okay. No.
I like to make my students make fancy bubbles.
No, I don't do bubbles. I do eyes.
Like a big eye?
A big eye and with eyelashes.
Like this. I think we're getting off track.
No, that's good. They'll know that.
And then, like watch out for it.
Watch out for it.
Clever. So make an eye or a bubble. And this is a bloodshot eye here. Okay, moving on. Sorry, guys. Okay.
No, last thing, this is a problem that you're going to actually find very often. It's where you have to fill in everything. That's called solve the triangle. Okay. So it says find to one decimal place all the unknown sides and angles of the following. So where do we start?
Okay. I'd like to start with an angle.
You want to start with an angle?
Yeah.
I'd like to start with labeling the sides.
You'd like to start? Okay. Well, so again, depending on which side depending on which angle you've picked as your angle of reference here, that's going to affect your labeling of sides, right? Okay. So I'm going to pick this as the angle that I'll be working with right now, which would mean that this is the opposite.
Right.
And then across the 90 degrees is always the fixed,
the
hypotenuse.
Not going to change, right?
Yeah.
And that one's going to be my adjacent.
And then that one is going to be adjacent. Good. Well, be very, very neat, because this is like a 5-6 mark question. You have a lot to find. So if, the person marking your paper can't tell what you're finding, it's a disaster. So I'm just going to label that the first thing is we're going to find theta.
That reference angle, right?
Okay. So now remember your SOHCAHTOA. Okay, Ms. Borbe, so can you help me? Which ratio I'm going to have to use here?
If I look at this, I know what my opposite is, and I know what my hypotenuse is.
Right.
Right? So I'm going to look for that and see that I need to use sine.
Yeah, there it is. Opposite hypotenuse.
So sine of theta is equal to 5/8.
Okay.
Then we need our calculator.
Now remember, angle alert, Angle means
Inverse.
inverse. Okay. So second sine.
36.7. Should we do 1 degree of 3 significant figures?
3 significant figures will be good. Okay.
So that's the angle now. Now we're going to move on. We need to find the other angle.
Is this phi? I think it's called phi.
Phi?
I think that's the Greek letter for it, yeah.
Oh, I don't know.
Okay, don't we?
We do.
Because I know this angle now, I know this angle now.
And I know that all 3 angles add up to 180
to 180 degrees. So what I can do is I can just do 180 minus 90 minus the answer that we found. And bam, that's going to give us phi.
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 Phi. Phi.
I have to check that I'm pronouncing that properly.
You know, you have to be really careful on these podcasts because if a kid finds a mistake, it's €1.
A euro who pays?
Miss Flynn.
Out of her wallet?
Yep.
That is a ridiculous rule.
So that means you're going to have to pay now.
I think a kid should contribute to Tanzania if he finds a mistake. It's his chance to do good for the world. Or her, ladies out there. Okay, so we've got the 2 angles now, okay? Now again, we still haven't found everything, right? We still need to find x.
Find that x. So there's lots of ways.
Lots of ways.
That. So what would you like to do?
You know what? Let's just do the easiest. Let's just do Pythagoras.
Pythagoras, that's
good. Well, we know that we have the 2 sides. Let's find the third. So, guys, if you wanted to try and do it with SOHCAHTOA, you should get the same answer. You try trig if you want to, okay? Now, be careful with SOHCAHTOA, right? Remember, this is the C, and then you've got your A, and then you've got your B. Okay? So I'm going to do it in red just because...
So I have x squared plus 5 squared is equal to 8 squared. We're going to subtract, 25 from both sides.
64, 44, 39. Good. And now, guys, remember to get rid of a square. You all know this already, that's the square root. And I always like to put the approximate because the square root of 39 is not going to be exact. Okay.
6.24. And does that make sense? That's the last thing you should look at?
Always, Ms. Borby. Good point.
Sure does, right? If you go up and you look at 6.24, if that came out to be longer than 8, you would know you made a mistake.
Because hypotenuse is always the longest.
Okay, that's it.
So there you go. That's your little introduction to right angle trigonometry and SOHCAHTOA. Hopefully, you understood and remembered it. If you don't, of course, come and see us.
Okay, thanks.
Good luck.